Welcome to Okonkwo Academy. In this tutorial, I'll be taking you guys through Quotient Rule and Chain Rule. If you are new to this channel, I recommend that you please subscribe and put us on post notification so that you'll be notified whenever we upload a video. Now, suppose we have a function of the form f of x is equal to g of x divided by h of x, and we are asked to find the differential of f of x. What we do is to use the quotient rule because this is a function that suits that rule. Now, throughout this course, we will be using functions of one variable, functions that depend on just one variable. The independent variable is just one. We will not have any functions that has two independent variables. Sorry. Now, if you are asked to differentiate a function of this form, what we do is to first use this formula. Now I'm coming to write the formula for the quotient rule. So what we do is that we first multiply the denominator by the differential of the numerator minus the differential of the denominator multiplied by the original numerator, and all this divided by the denominator squared. The denominator squared. Okay, so with this we can solve these questions. So sometimes people tend to forget how this formula works and whether or not to first of all differentiate the denominator and keep the numerator, because if you do that you're going to change the expression. If for example you put you first differentiate this and multiply it by g of x, if you interchange it, you get a negative of the original expression that you get. So you can keep this acronym in mind, that first come first serve. So you always have to differentiate the numerator first, multiplied by the original denominator. First come first serve. So we differentiate the numerator first, then we keep the denominator minus the differential of the denominator times the original numerator, all divided by the original denominator squared. So now let's solve an example. So with this example, what we do is we differentiate the numerator. So when we differentiate the numerator, we are going to get 2x. This numerator we get 2x. Now if you don't know how to differentiate a function, please, I'll put the link to our previous video on how to differentiate a function so that you get to watch that. Then for the denominator we get 3x because this is a constant, and so if you differentiate a constant you get 0. Okay, so first of all, first come first serve. So we keep we keep the denominator plus 7 and multiply it by the differential of the numerator, which is 2x, minus the differential of the denominator, which is 3x, multiplied by the original numerator, which is x squared plus 4, all divided by the denominator squared. Now simplifying this, we are going to get 2x to the power 4 plus 14x minus 3x to the power 3 minus 12x all divided by, sorry, the denominator squared. So all divided by the denominator squared. So you just rewrite this for, then we get 2x to the power 4 plus, sorry, minus, so minus 3x cubed plus 2x all divided by x cubed plus 7 squared. Now this is how to solve a function which is dividing each other. You use the quotient rule. Now let's solve an example on the tan x. Now let's say we have tan x. We know that although this is not in a form f of x over g of x, we can write this in that form. We know that tan x is equal to what? Sine x over cos x, right? Now let me use this opportunity to show you guys how some trig functions. So when we have 1 over cos x, we call this sec x or secant of x. When we have 1 over sine x, we call this cosecant. So cosec of x. When you have 1 over tan x, we call this cotangent or cot of x. So when we are asked to differentiate this function, you write it in the fractional form, which is sine x over cos x, right? So as you already know, first come first serve. So we have to first differentiate the numerator multiplied by the original denominator minus the differential of the denominator multiplied by the original numerator all divided by the denominator squared. First come first serve principle. So differentiating sine x, differentiating sine x, we get what? Cos x. Differentiating cos x, we get negative sine x. So using the first come first serve principle, we first write the differential of the numerator multiplied by the original denominator. The denominator is cos x minus the differential of the denominator, which is sine x, negative sine x, sorry, multiplied by the original numerator. So that's divided by the denominator squared. So you see, if you simplify this, you are going to get cos squared x plus sine squared x all over cos squared x. If you remember in SHS, we got to know that cos squared x plus sine squared x is equal to 1 from normal trig principles. And we learnt this in high school that cos squared x plus sin squared x is equal to 1. So we are going to get 1 over cos squared x, right? So this can also be written out as 1 over cos x multiplying 1 over another cos x, right? So as we've said here that 1 over cos x is equal to what? Sec x. So I can rewrite this as sec x squared or sec squared x, anyhow you write that. Hence we've proved that tan x, differential of tan x will be equal to sec squared x. Now let's move on into the next concept that we are about to learn, which is chain rule. So most of the time when we have a function of the form, let's say ax plus b, we can differentiate this simply with our power rule, where we say that we are going to get, let's say n here, where we say that we are going to get a multiplying n, that expression multiplying x to the power n minus 1 plus 0, because b is a constant. So this will be very, very simple. Now let's say we have a function of this form, but now we have that to the power, let's say 2. So if we didn't know the chain rule, like what we will do is that we will need to expand this bracket, then come and get an expression for this bracket, then we use the power rule to solve it. But let's say when now it's not just 2, because 2 is simply, sorry, 2 can simply be simplified, right? So we can just find an expression for any expression to the power 2, and that would be easy. But let's say we have that to the power 100. We can't say we will simplify 100 times. That would take our time. That's why the chain rule was introduced, to make it easy for us to solve higher power differentials, right? Higher power differential. So with this, when we want to use the chain rule, what we do is that we replace the expression in this bracket by a variable. So let's say u. Here I'm going to use u as my variable. So we say that let u be equal to x squared plus 90, so that the function would be now a function of u, for us to get u to the power 91. So what chain rule basically does is that it multiplies two differential such that we will get the original differential, right? Now we know that the differential of f of x is supposed to be written in this form. The differential of f of x will be equal to this, right? This is how I write the differential of f of x, the first differential of f of x. So it will be in this form. So we will write these two expressions such that when we multiply them, when we multiply these two expressions, we are going to get the differential of f of x, right? So first of all, I will differentiate this expression and also differentiate this expression. So when I differentiate u, which is a function of x, I'm going to get du over dx, and that is going to give me 2x. And when I differentiate f of u with respect to u, I'm going to get 91 u to the power 90, right? So for me to get the differential of f of x, I can see from this that I have a denominator of the u and I have a numerator of du and I have a denominator of du. So when I multiply these two, I'm going to get the f of u over dx, right? So let me multiply these two so that you get to see what I'm really talking about. So the f of u over du multiplying du over dx, right? So now I'm getting closer to this expression, because when I multiply the two, it means that the u will cancel the u for me to get the f of u over dx, right? So let's multiply it. Now what is left is to change this u to this x so that I can get this differential straightforward. So I'm going to get 2x multiplying 91 times u of 90, right? So I'm going to get 182x multiplying u of 90. Now this is the f of u over du. Sorry, the f of u over dx. Sorry, the x. For me to change this the f of u to the f of x, I just need to replace this u by the expression here, because I said u is equal to x squared plus 90, right? So I just replace u by x squared plus 90 so that I get 182x multiplying x squared plus 90 all to the power 90, so that I get the function. Now this u has been converted into x so that I get the function in terms of f of x. Now this is how to solve the chain rule or an equation, the differential of an equation using, the differential of an expression using the chain rule. Now I'll leave this to you to solve with the chain rule and tell me the answer in the comment section. I'll do all to check your comments, and also please like and share our video to your friends who have problems in chain rule and quotient rule. Thank you.